So we're back live. So these were the simple circuits we tried before. Now we will try this example from the first tutorial. Let's draw it here to remind ourselves. It's of course good to turn on the mic first. Okay, so a C naught in MVQC. So there we have 4 qubits. And 1 and 4 are the input states for this C naught gate that we're going to do. And then, so this is 4 is the control and 1 is the target. And then the output will be the target is number 3 and 4 is still the control. So we want to do some operations on these qubits such that if 1 and 4 are the input states, then 3 and 4 will be the output states for a C naught. So how do we do this? Step 1 is to put 1 and 4 as the input states. 2 and 3 we put in the plus state. And then step 2 is to do CZ gates on all connected pairs here, so all these 3 lines. So 1 to 2, 2 to 3, and 2 to 4. And then number 3 is to measure qubits 1 and 2 in the X basis. So in the quantum computer we have access to measurements in the Z basis, so we need to do a rotation, a Hadamard, to make this effectively a measurement in the X basis. And then step 4 is to do feedback. And that's some feedback operator on the state psi that you have after these operations. And we derived in this exercise, in the tutorial, that this feedback operator is Z on 3, Z on 4, power M1, and then X on 3, power M2. M2. So this, when we measure qubit 1 in the X basis, the measurement result is M1. And when we measure M2, the measurement result is called M2. So it's a 0 or a 1. And that depends, gives them which feedback operation we should do. So, can you now implement this scheme on, on the actual quantum computer and see if you can make it work as a student? That's the larger task for this computer. If you are some KISS-KIT experts, and this is something you do quickly, I would say you can try doing the same thing for the last task of the first hand-in, which was also MBQC, but a different setup with just 3 qubits and a different entangling gate here in step 2. You can see and compare them. But for now we try to implement this. And here I would recommend that you look at the layout of the chip that you want to implement this on, so that the layout actually corresponds to the layout that you have here. Because if it doesn't, then the machine, it will compile the program to implement it on a specific chip, and it will add more gates here. But there are chips where you have 4 qubits in a layout like this. Okay, good luck.